Okay, my name is Tabanik. This is the low pass filter. Here on the circuit, we're using a couple resistors as well as a capacitor. So because we don't have a 1.5 kilo ohm resistor, we actually use 3 resistors. We have these 2 resistors connected in parallel, and that is then connected in series with this resistor. They're all 1 kilo ohm resistors, giving an equivalent resistance of 1.5 kilo ohm. Those resistors are then connected to a capacitor of 0.001 microfarads. And then the probes are connected. One is connected to the input voltage, and then the other one is connected across the capacitor. So if you take a look at the waveforms, you can see what we did is we did a network sweep. And the reason, like this being a low-pass filter, what you can see is that at low frequencies, the low frequencies are passed through, while high frequencies are rejected. So you'll see that the cutoff frequency is about 95 kilohertz. In terms of the phase shift, the bottom graph represents the phase shift. In a low-pass filter, the output lags the input, meaning that there's a negative phase shift. So this right here is the band-pass filter. So it's very similar to the low-pass filter, except we have an inductor connected in parallel with the capacitor. So if you take a look at the waveforms, we ran a network sweep, and the thing about band-pass filters is that there's a resonant frequency where the gain is maximal, and that occurs around here, which is about 87 kilohertz. Also, if you look at the phase response, in bandpass filters, the output leads the input, meaning that there's a positive phase shift.